we can see a particularly clear and practical example of Lenz's law if instead of looking at transformers, we look at magnetic braking. So what I have here is a metal disc that's free to spin. Okay, so it spins happily. Now, if I were to put that in a magnetic field, it would be a conductor moving in a magnetic field, and so we'd expect, from Faraday's law of induction, that eddy currents, little circles of current, would be induced inside that disc. And they would, in turn, produce their own magnetic fields, and the question is, in what direction are they going to do all that? And the answer is very simple. They have to oppose the motion, don't they? And so if I just put this magnet around that disc, it stops the disc rather rapidly. This is a nice strong magnet, and indeed it didn't involve any touching. If I show you directly, you can see the disc spinning. There it is, spinning nice and fast. As I bring the magnets in, the magnetic field induced a current that opposed the motion, and so what we ended up with was a stopped disc with no touching. And that's magnetic braking. It's a very handy tool. And again, this is just a restatement of the conservation of energy. If magnetic forces that were induced helped the motion, helped accelerate the motion in that direction, then of course you'd be getting kinetic energy out of nowhere. We can do another fairly clear demonstration that what's going on in magnetic braking is in fact to do with currents being induced inside the material. And the way we do that is we have magnetic braking where we have different materials. So what we've got here is we have three magnets at the bottom here. And those three magnets are in tubes, and there's plenty of room for them to slide down those tubes. But those three tubes are made of different materials. We have clear plastic, which is not a conductor. We have aluminium, which is a conductor, and copper, which is a really good conductor. And so what I'm going to do is I'm going to take this, I'm going to tip it upside down, and then each of these three magnets will just slide down the tube into the other end. Okay, let's see how long that takes. Extremely different times. You'll see the plastic went down, bang, the aluminium came down a bit slower, and the copper was surprisingly slow. And indeed, if you take these and make them cold, resistivity goes down as you make things colder, and so you can find that the currents really, really slow the motion of the magnets, and it gets slower and slower as you make them colder.